Hi everyone, in this video let us understand how to solve linear programming problem. The problem is taken from class 12. So the question is maximize. So this is our objective function. Z is equal to 4x plus y subjected to the constraint. So what is the constraint here? X plus y less than or equal to 50, 3x plus y less than or equal to 90, and the positive constraint, that is non-negative constraint, is x greater than 0 or equal to 0, y greater than or equal to 0. Let us first analyze the given question. So the question is objective function is to be maximized. So whatever the value of x and y after plotting the graph we get, on substitution you have to identify the maximum value of this function. That is called maximizing the objective function. And the constraint x plus y less than or equal to 50, 3x plus y less than or equal to 90. So let's start the solution. When we are studying a graphical way, less than or equal to or less than or equal to or greater than or equal to cannot be plotted on the graph. So instead what we do, the condition satisfy for less than and equal to, so we will take at equal to. So let x plus y equal to 50. Now give the suitable value for x. When x is equal to 0, y is equal to 50. Similarly, when y is equal to 0, x is equal to 50. Now what is the second constraint we have? 3x plus y, instead of less than equal to 90, I will put equal to 90. What we have to do? Let me put x is equal to 0, y will be 90. Y is equal to 0, 3x is equal to 90, so x is equal to 90 by 2, 3. 3 ones are 3, 3s are, so 30. So to plot a graph, it's more than enough having two values. So let's start plotting the graph. So write the table before that x, y. X is 0, y is 50. Y is 0, x is 50. This is the first table. And the second same, x and y. When x is 0, y 90. When y is 0, x 30. So now our values are ready to plot. Let's plot the graph. Since we have the values from x50, x90, y0 to 50 and so on. So what we'll do, we'll take a scale, intersection of x-axis, y-axis. Since there is no negative value, I am not going to take the negative axis even though it is exist. Now 0, let me take 10 units, 10, 20, 30, 40, 50, 60, 70. Since x is maximum up to 50, this is more than enough. And y is maximum up 90. So vertically 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Enough, because we don't have more than that data. Okay, so we'll take this point as A and B and this points as C and D. Let's plot the graph. X is 0, y is on positive 50, so this is A value. X is 50, so x is 50 on horizontal line, x is 50 and value of y is 0, so this is this. These 2 points we got it from one equation, so I will connect these two. Since it's a linear equation, it will be a straight line. You can extend the line how much ever you want. This is a line, x plus y equal to 50. Similarly, x is 0. This is x0, y vertically 90, positive axis. So this is y, denoted as C. X is 30. The value of y is 0. this is 10. These 2 points are obtained from one constraint, so we'll connect it. Again, it's a straight line. You can extend the line for further reference. Okay. Now we need to closely observe the bounded region. So what are the bounded regions? This is an intersection, so I'll just denote it as E. Now what are the bounded regions? The bounded region are, so you can see here one bounded region. Bounded region are nothing but the closed curve. ACE is one region. One more is here, that is EDB. One more is, I'll denote it as O, so it is AOD and E. AODE. Now among this 3 bounded region, we need to analyze where exactly the solution exists for the given objective function. So what was the objective function? Z is equal to 4x plus y. This is our objective function. And here the scale, x-axis 10 units, y-axis 10 units. So to find that, what we have to do, we have to analyze the curve. So let's start with the line x plus y is equal to 30, and this line is 3x plus y is equal to 90. Now read the constraint. The line x plus y is less than or equal to 50. So where is the line? This is the line. X plus y less than or equal. So what I have to do? Draw downward arrow mark. Because it is less than. The value is less than or equal to 50. This is up to 50, so the value is less than 50. Okay, I hope that you got this point. Now, what is the next condition? The second line, 3x plus y is less than 90. So, less than 90. So, this is up to 90. Okay. This is the line which we have taken for 3x plus y. Okay. From this line, draw a downward arrow mark. Okay, I hope this is clear to you. Okay. Now see both the 3 bounded region. What are the 3 bounded region we had? A, C, E. So this is A, C and E. Since there were 2 lines, see that 2 lines are intersecting or not. You can see this region has only the line of 3x plus y. There is only one line. So this is not feasible. Okay. Excuse me. So now check the region EDB. Where is EDB? This portion. EDB. Here also you can see only one line is coming. Feasible region is nothing but intersection of 2 given constraints. So this is also not feasible. Okay. Now what is the third bounded region we have? E, D, O, A. You can clearly see that there are the intersection of 2 lines. See, here one line, here one line. Here one line, here one line. Here one line, here one line. So that means 2 equation has a common point at this location. I hope this is clear to you. 2 equations, constraints are having common point at this location. This is the region. This is called feasible region. So what are the points we have in this feasible region? A, which is 0, 50. O, which is 0, 0. D, which is 30, 0. And this point is an intersection of these 2 lines. So you can check x is 20, y is 30. 20 comma 20 comma 30. These are the bounded points where the solution exists for the given objective function. So what is our objective function? 4x plus y, correct? Substitute the value when x is 0, y is 50. So 50. When x is 0, y is 0, 0. X is 30, 4 3s are 12. So it is 120 plus 0. X is 20. 4 2s are 8. So it is 80 plus 30. 80 plus 30. 80. 4 2s are 8. 80 plus 30. So it is 8, 9, 10, 11. So what are the values we have? 50, 0, 120, 110. But what is the objective function given in the question? Maximize the objective function. Among this, what is the maximum value? Which is 120. At what point x is equal to 30, y is equal to 0? I hope you are able to understand this concept. So in the next video, we will come across few more exercise problems related to this chapter. Thank you.